Hey, it's Rich, the Louisiana hobby guy. So you're getting that dreaded error 9 message, shock and movement detected, and your machine just turns off. Well, I've had a lot of people contact me with this problem over the last few months, and I decided today to do a video on it because there may just be a very simple solution to this problem that most people don't realize, and it has to do with the size of the work area. So let's jump into the video real quick and let me show you how I fixed quite a few people's machines and stopped this shock alarm from happening. So let's jump into that right now and take a look. All right, so I'm in Lightburn now, and what I've done is I've drawn a rectangle here, and I've set this to 400 by 450 if you look up in here. This is the work area of this laser. This is the Laser Man by Flying Bear. At 400 by 450 it doesn't work, and let me show you. I'm going to do a quick frame. Watch what happens. I got the camera out over here. This is the alarm light. You'll hear the buzzer, so watch. Okay, so what happened? I know that it is not 400 by 450, and that is the problem. So if I change that to, let's say 444, I think it was the number that I found was the right number. So let's go 444 and press enter. And now if I click on the center here, come up to the top and center it perfectly with this crosshair. If you don't have these crosshairs up here, it's because you have the arrange toolbar up there instead of the arrange long. So if you don't see these crosshairs up here, just right click on the white space here, okay? Uncheck arrange and check off arrange long, and this will pop up for you. All right, so now we've got this set directly to the middle, and let's go ahead and home the machine. Now let's give it a try now. Now you see that didn't work either. So I'm going to home the machine one more time, and I'm going to set this to 399. 399, press enter by 444. Now I'm going to click on the center. It's very important you do this part right here and center it on the workspace. Now I'm going to hit frame. And now you'll see that it's going to do a perfect frame in every direction. So it was off slightly on the X, and it was off slightly on the Y. And that's the problem with the machine going out of bounds. Now, a lot of machines don't have this alarm where it stops without giving you an error message in the console. This one does. So that was a perfect frame at that size. If I change the size, let me just change it to 445 and press enter. Click in the center here on that center handle, center it on the workbed, and hit frame. And what I should have done, I should have changed the speed over here on the move tab to 10,000 so we don't waste so much time. Well, we got it set for the next one. Well, you heard it hit just then? It hit, but not hard enough to trigger the alarm. So at 445, sometimes it works, sometimes it doesn't. So let's just run it again. Now that I've got it at 10,000. And you want to run this at your maximum speed as well. And that all worked fine. So 399 by 445 is the actual bed size without throwing an alarm on this machine. On your machine, it might say, you know, that you're going out of bounds, or it might run into the rail and keep trying to go. And, you know, you'll hear the timing belt jumping teeth, bump, 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 up against the rail. So now watch what happens. I'm going to set this back to 400 and press enter. I'm going to click on the center handle, center it, and I'm going to frame it again. Sometimes it works, sometimes it doesn't. Right there, yep, right there in that corner is where I have the problem. So that's why the 400 doesn't work in the width. So I have to set this to 399 and press enter. Then click on the center handle, center it, and now when I frame, I have no problem. And like I said a minute ago, on some lasers, now it does hit that back, but it doesn't throw the alarm. So I'm not too worried about it. It's working fine. On some lasers, it's gonna keep traveling, and it's gonna make all kinds of god-awful noises. And I hear lots of people asking me about this, and it may just be a tolerance problem with the laser that you've got. So I just wanted to make this quick video today to show you how to solve that. And it's as easy as just taking and grabbing a primitive over here and drawing out a rectangle and setting it to your size in here. So on this one, it's 400 by 450, or that's what the manufacturer claims, okay? It is not. So let's go ahead and fix this in here now that we know what the right settings are. It is 399, oops, not 39.99. 399 by 444 is the correct size of this work area. And now if I click on this and center it, you'll see that is my total work area right there, where it doesn't hit any hard stops, doesn't hit any of the frame, doesn't go into alarm, and in some cases won't hit the rail and keep trying to go. So this is one thing that you might want to check on your machine if you're having problems with it running into the rail and making lots of noise. And just to add a little more to this, if you want to know on your move tab over here what speed you can set this to, on this one I can set it to 10,000 millimeters per minute, as you can see here. So if you want to know what speed that you can set it to, you come over to your console and you type in here $. Now you get a result from the control board that the $110, $111 will give you your maximum speed on your X and Y. And in this case, it is 10,000 and 10,000. So I just wanted to add that real quickly, just to show you how you can get your maximum speed reading and know how fast you can set your speed on the move tab. And also another spot too is up in here, a fast white space scan. So it tells you right here, this is what I've set it at, 10,000, because I've already checked it. So your fast white space scan is the amount of time that it goes back and forth, and you don't want this to be turned off. On default settings, it's going to be off. You want to make sure that it's on and set it to your maximum speed so that when the laser is not engraving, when it's scanning back and forth, it'll move quickly and save you a bunch of time on your job. And now finally, the last thing is we're going to take a look at the preview window up here, and it's going to give us a time. And actually on this one it's not, because let me just turn off cut select graphics, get rid of that, come to the cuts and layers and turn on my output over here. So this was the file I was working on when I had problems with the laser bed size. So now if I come up to the preview, you'll see I've got 1 hour, 3 minutes, and 14 minutes is the time that it's going to take to do this test that I'm doing on this laser. However, it's not always accurate. So if we come back up into the device settings, which is this little wrench and screwdriver icon up top here, and we come over to additional settings. If you don't read this from the controller, Lightburn is not going to know what it's supposed to be, so you have to click this button down here that says read from controller, and these numbers here will change. Now when I click read from controller, they didn't change just because I'd already done this, but prior to this these numbers were different. This was 300, this was 300, and when I clicked read from controller, it brought in all of these numbers. That this tab with the additional settings and reading from the controller will give you an accurate number in your preview. Well, it won't give you an accurate number. It'll give you a better estimate of the time the job is going to take. Even Jason from Lightburn, the developer of this software, has admitted that this is just a guesstimate, the preview time. So this is going to be a best guesstimate if you come in here and read your controller settings, because Lightburn just doesn't do this automatically. So if you're first setting up a laser, come into the device settings, go to the additional settings tab, and click that read from controller button. All right, so let's talk for a second about what causes this. And there are two main causes for this. It can be a factory cause, it can be a user error. So let's cover the factory cause first. You may have a laser that's been delivered to you. It may be an inexpensive laser. They may use inexpensive parts. They may have tolerances that are just slightly off. Just a half a millimeter off can throw off your laser and cause this to happen. Now, in most cases, it's not going to be a factory error. In some cases, it can be, like this particular one that I just did. In most cases, it's going to be during your assembly when you put the machine together. The machine is not going to be perfectly square, and you take the square off by just a little bit, and it elongates, one side or the other, and that throws off your dimensions. So if your machine is not perfectly square, and when I assemble machines, I always assemble them loosely. I put all of the screws in, and then I get my metal framing square, and I put my metal framing square into the corner and hold it there while I tighten those screws. And I make sure that there is absolutely no movement and that there's no gap in that framing square before I move on to the opposite corner. So I'll go from the bottom left corner to the top right corner, then I'll screw that one in and tighten everything up there. Then I'll move to the other two corners. And you have to make sure that that frame is perfectly square when you assemble it. In most cases, probably 70 or 75% of the cases that on assembly, it's going to assemble square because of the way that the parts fit together, but not all cases. So now the second thing that you have to make sure is that the gantry is square to the frame. This is probably the biggest problem right here. And the way that I do that, if you're installing timing belts, and I know a lot of them don't come where you have to install the timing belts anymore, but if you are installing timing belts, or even if they're pre-installed, you'll want to make sure that when you slide the gantry all the way to the end of one side or the other, that it's a dead stop and it's even on both sides, square to the frame. And when I'm doing the ones with timing belts, I'll bring it all the way to one side. Then I'll adjust the timing belts on the opposite side, pulling tension from the opposite side with the most amount of distance between it before I tighten that down, move on to the other side, do the other side, and then make sure that it's still square against the bottom of the machine. Then bring it all the way up to the top and make sure that it hits the rails exactly at the same time on the top. So that is another reason, and those are probably the two main reasons why the machine is throwing this error. Now on this machine, those weren't the reasons, because I verified it. Then when I had the problem, I verified it during the assembly first. And then after I had the problem, I went back and verified it again with my framing square, and I made sure everything was perfect, and it was. So in my case, this was a factory tolerance problem, and not necessarily a user assembly problem. Okay, so this may or may not be your problem. It is by far the most common problem that I've found with people that are messaging me for help. When I log into their computers and take a look at their settings, and I run the frame job like I did in the video, we find out that the laser drives directly into the rails. And then when I adjust the size, well, that fixes the problem. So like I said, this is the most common problem. It's not the only problem. There are some machines that have their like for instance, machines with limit switches, they have their bounce set up where when they hit the 0, position, it's going to bounce off a half a millimeter or a millimeter. In some cases, on this machine that I was using today, I believe it was 0.45, and even that 0.45 didn't work. So I had to take a whole millimeter off of the X and quite a few off of the Y. But there's that bounce for the limit switches. The machines that have the hard stops are a little bit different. They'll stop exactly at the 0, 0. And if you had moved that laser head just the slightest bit, it'll drive into the rails not knowing where that 0, 0 was because you've moved it. Once you move that laser head by hand, even if you just bump it a little bit, it's not gonna record that, and you're gonna wind up hitting the rails. So the best thing, and the thing I always tell everybody, is to use the home function. Now, if you don't know how to home the laser, I'm going to do another one following this that probably next week sometime about homing a laser without limit switches. I've done it. I've done examples of it in a couple of my review videos. You can go take a look at those. I'm not sure which video it was. I think, let me look real quick. I'm pretty sure that you're going to find that quick cheat tutorial, the hack on setting a home position, in the video I have titled Honest Review of the Two Trees TTS 5 diode laser. That's hard to get out. Anyway, I'll put a link to that below in the description. You can go to that review and skip forward, and I'll put the timestamp where you should skip to as well down below in the show more section. And you can learn how to home that laser that doesn't have limit switches, and then you can work from that home position all the time. So it's important, as far as I'm concerned, that you home the laser in between every job. So if I'm running a job and I've homed the laser and I run that job and then I realize, oh gee, I need to make another pass. Well, even with a laser without limit switches, you can emulate that homing, and you can send it back to the 0, 0 position by using the hack that I show you in that laser review. And then you can just run the job again, and it's going to run perfectly. So you don't necessarily have to have homing switches. You don't have to have an advanced laser, anything like that. You just need to know how to set a home position and go to it. And I always recommend homing the machine before starting every job. And the reason that I recommend that is because you know that it will never go out of bounds. And you know that it's starting from the 0, 0 position. And in my case, I create a wasteboard. I burn that wasteboard, a grid on there, and I have a video on that as well, burning the wasteboard grid. And all I do is I take and drop my workpieces onto the grid, line them up on the grid. And then I go ahead and hit start. I load that grid that I used to burn it with in Lightburn. I center my graphic on one of the squares, and I go ahead and hit start. So no framing involved in most of the work. 96% of the work that I do, there is no framing. So that's another one that you might want to take a look at, working in absolute coordinates. And I believe that working in absolute coordinates is the only way to be really productive with a laser machine. So if you're going to do this as a business, if you're going to be doing production work, 100, 150 items, all of the same thing, then you'll want to work with a grid. You'll want to work with a wasteboard that has a grid burned into it, where you can do 9 items at the same time, do all 9, shove them off the workbed, put 9 more in the same spots, hit start, and just, rinse and repeat. So that's about it. And I know that a lot of people are having this problem. I know this will probably solve 70 or 80% of the problems that are out there, because just from my experience with people asking me for help. So I hope this helped you. So I hope this video helped you today. And as always, I thank you for watching, and I'll see you in the next one.